All right. So, hello. We are group number six. I'm Dominic, and I worked with Gabe, Sam, Henry, and Hallie. So first, obviously, we started off with cleaning our data. We thought that was gonna be very important to help us make good plots and do good calculations on our project. So we imported the five data sets from the CDC regarding smoking. These were uh, age, employment status, income, mental health, and then race and ethnicity. All these data sets had the same structure, so we first merged them using bind rows and create a data frame called DISP. We could use this then throughout to analyze and make more plots. Next, we cleaned up some of the missing values in the data. So some of the in the actual data itself, there was like missing entries, so there could be, let's say, no data or NA. So we converted those into proper NA values, so that when we're making the calculations later on, there wouldn't be no issues. We removed the tobacco use column because that was pretty constant across all the data sets. It really didn't provide us with anything meaningful, so we felt there was no need to have it in our data. We standardized all the column names. We used a vector that we make clean names so that every data set has similar structure. So that was easy when comparing all of them. Um, so we also fixed the data types. So for example, the year variable, we converted to an integer. Prevalence and disparity values, we converted that to numeric. Categorical variables like state or demographic type were converted to factors. And then this is just so that interpretation in R itself was very easy. And then once it was cleaned, we recalculated the true disparity values ourselves. We divide the focus group smoking prevalence by the reference group prevalence, and we created a new variable called diff ratio. We also created a diff ratio variable, or diff variable to represent the absolute true difference between the two groups, and we verified all of these things and recalculated ratios uh, throughout. Overall, this process ensured that when we would go to make the plots, that it was a smooth process. It showed what we want to actually show, and there weren't any bugs in the process. And then now we're going to discuss some of the plots that we made um, for our project.
Yeah, so to make these plots, we pretty much just went through and we actually created some of the single demographic data frames. We already started with those and we ended up combining them, but we thought that once we clean the data, it would make sense to split them back up just in case we needed to use them for anything. And then that way, all of those data sets would have the same cleaning steps that we did without having to do all five. The first plot that and the one other thing that we did do is we also made the prevalences data frame, which just covers the you have the disparities calculated between the ratio of two prevalences between a focus group and a reference group. So we just made the prevalence group to just look at each focus group um, per each year, per each state. So we found that that calculation was easier to interpret in some cases than the disparity value. So the first plot that we ended up making was our missingness analysis. As we saw during the cleaning step, there was a lot of missing data, and we wanted to understand a little bit more about what that actually meant, because different missingness can have different effects on our analysis. So the first plot that we made was this heat map of disparity value missingness by year and state. So this can just show us whether different states, like how that missingness works. Like did states have just kind of random spots where they didn't report data, or maybe were things a little bit more just spread out. We can see that these top states here, as it is sorted by the amount of total missingness, that these top states tend to struggle from more chronic missingness. They have issues with missingness throughout the entire period, whereas these states here on the bottom, Washington is actually the only state to always report their data. They had no missing values throughout the entire period. And as we can see, it's a little bit of a gentle gradient where, for the most part, as time went on, missingness tend to go up. And then throughout these different states, it doesn't really appear that there's a specific trend with any of these states. It just seems to be different reporting habits within the CDC and within the states. And we also see that these bright red values, if the missing number missing is 64, it meant that they didn't report any data for any of the demographic groups that year. And we see that that only occurs 4 times in these dark red areas. So everybody else, they're reporting a mix of missing data and full data. But all things considered, it's a pretty complete data set. As we did a separate analysis that's not included in this plot, showed that even the District of Columbia still was able to report 90%, over 90% of the data, which is good because it means that we have a lot there to analyze. The next thing we looked at was the distribution of national average smoking prevalence by focus group. We faceted this by demographic. So this just shows us the prevalence over the entire period. So we can see in the age category that 25 to 44-year-olds tend to have the highest smoking prevalence, followed closely by 45 to 64-year-olds. We also can see that people who are unable to work um, and people who are unemployed have a much higher prevalence than the other groups here. Then in the income group, we can see that as the amount of income that you make increases, the the less you tend to smoke, with people who with less than $20,000 of income smoking the most. Similar scenario with mental health, as people with severe mental distress smoke much more, and then as that mental distress decreases, we see a lower smoking prevalence. Lastly, with race and ethnicity, we see that non-Hispanic American Indians and Alaska Natives smoke much more than any of the other groups. And as we'll see in some other plots, that this means that they have a higher average disparity than others. Um, so we can move on to a related plot, which basically takes this plot up here, which is useful for in-group comparisons and splits it up over across demographics. This is useful because we can kind of see it's a lot easier to compare, the prevalence for maybe someone in the race and ethnicity category compared to a group in the age category or something like that. Here we can see that people who are unable to work, non-Hispanic American Indians and Alaskan Natives, less people with less than $20,000 of income per year, people who are unemployed, people who experience severe mental distress, generally people who are more susceptible on average to a lower socioeconomic status, more likely to encounter more social and economic hardship, tend to smoke a lot more than, say, people who might have a more secure situation. No mental distress, you're younger, you're, retired, or you're a homemaker or a student, which means that you tend to have your life maybe a little bit more regular life situation than some of these people in these higher groups. So that was a hypothesis that we were able to form from these graphs, and something that we will try to explore just a little bit more throughout the rest of the plots. This last one that I'll talk about here is the distribution of national average disparity by focus group. And this one just kind of breaks down this similar idea. Above we have with the prevalences, just now we see the disparity, which means that this will be their difference from the other groups that are around them. So the more inequality that this group experiences relative to everybody else, the higher this average disparity value. And we can see this red line right here just indicates the parity line. So people who are on the left side are going to be seeing less compared to their other groups, and the people on the right side are going to be seeing more. People right along this line are going to be pretty average in terms of the smoking prevalence. And we see similar trends as we saw in the previous plots reflected here as well. I'll pass it off.
Awesome. Thank you, Sam. Yeah. So the next thing that our fifth plot here is just going to be the overall national average smoking prevalence over time. And we broke this into the five different data sets. And the biggest thing that I think we really want to call attention to is that among all five of these data sets and all five demographic groups, we see that smoking has really decreased over the last 12 years. And we think that this is because of, number one, the substitution effects, whether it be e-cigarettes or any other forms of using nicotine, but also because of policy reform and just overall health, people being more aware of the overall health impacts that come with smoking. We think that this was really interesting. Next, we can sort of look towards the average smoking prevalence specifically by state and the income groups. So the biggest takeaway that we can sort of gain from this graph is the inverse relationship between income and then their smoking prevalence over time across states. So what we can see from here is that states like Kentucky, West Virginia, Alaska, Ohio, et cetera, overall, we pulled this from an outside source, but have a lower median average income by household in these states. And we see that higher smoking prevalence, which really helps us build the hypothesis that Sam was building on earlier, that with higher income, there's going to be less smoking, and with lower income, there's going to be a higher usage of cigarettes. The wealthier groups, obviously like states like California, exhibit these lowest rates, which reflect higher awareness and maybe the ability to spend money on these other areas. The next plot is we're going to look at a chloropleth, which is the average cigarette usage by state. And this is once again using the average prevalence that we see in these states. I think the biggest thing that we really stuck out to us from this map was looking at Utah specifically. They have the lowest prevalence out of all the states. And some of the hypotheses that we formed come around them having a very large Mormon community where things like smoking are banned from their religion. So we think that was really interesting. This cluster also allows us to highlight the different regions that we see that smoking may be a lot more common, specifically in Appalachia, where we see Kentucky, West Virginia, et cetera. So we think this was really cool. Now moving to the next one, this one shows the average disparity by state. And once again, sort of calling your attention to Utah, we see that they have the highest average disparity, yet they have the lowest smoking prevalence. And we think that this is, once again, because as you get these smaller groups and smaller data sets, you're more likely to see a lot more influence from the outliers and whatnot. And we think that's what sort of led to this higher average disparity, because there's a lot of groups that are higher income and don't smoke in Utah, but at the same time, there are a high concentration of those groups with less income that are smoking and largely not part of the Mormon community is sort of the hypothesis that we came to. So now I'll pass it over to Gabe to go through our last two plots.
Yeah, so now that we've looked at the disparities throughout the states and then the prevalence throughout the states, we thought it'd be interesting to see if they were correlated at all. So we made a scatter plot to kind of see this. And so by the scatter plot, you can tell that the line, yeah, it fits to the data, but there's a weak negative correlation, which kind of just implies that the smoking rates in a state and the disparities aren't really correlated. They don't really match up, which makes sense if you can see Utah all the way up here at the top. So many people don't smoke in Utah because of whatever norms or rules they have there. But because when you look in the groups, a certain group might smoke so much more, that's why their disparity is higher. So it's kind of interesting to point this out, and that's kind of why our discussion led to here. So moving forward from here, we kind of have bar chart that kind of wraps up what states kind of have the highest prevalence. So what we did is we created a risk score. So we looked at the top five like most prevalent things within each demographic group and gave each state a score of 1 if they fell into it. So if you can see at the top that West Virginia and Kentucky both have 5, meaning that across all demographic groups they scored in the top, which is pretty crazy. So it kind of shows that these states have more of a risk within that. So and that kind of sums up all of our plots. I'll pass it off to Hallie.
Awesome. So the next thing we had to do was create. Oh wait, am I sharing the PDF for this part too? So the next thing we had to do was create our model, obviously. So I just went through basically each of the variables in our DISP data set and did some small calculations to see if we could toss out any variables to begin with before actually making any models. So the first variable we're going to look at is focus group cigarette use. So I just calculated the correlation as well as made a small plot to kind of show the correlation. As you can see, 0.62, it has mild positive correlation, which the plot also shows. So I decided to include focus sig use in our model, which is expected because it's directly used in the calculation of disparity values. So that would make sense. Because it's used in the calculation of disparity values, that means we can't use the reference group cigarette use. Otherwise, we introduce multicollinearity, obviously, because then it would be the outcome variable would be affected by the two things that create it, which doesn't make much sense and creates some difficult beta coefficients to work with. Next up was year. That basically had no correlation at all, so I cast that one out. After that, I did ANOVA analyses on all of the categorical variables. So we start with state. The p-value here is really significant, but the effect, the sum of squares there, is actually pretty small. I'm assuming the p-value is significant just because it has a large sample size, 50 states, rather than the demographic or focus groups, because those are obviously smaller. So I cast out state from this model as well because it's just a little too complicated and not enough effect. Demographic, the effect is a little bit bigger here, but still not extreme. It's very moderate. I suspect that focus group will be more meaningful. It's also advantageous to split up demographic because we want to use all the demographics in the model, but I'll talk about that a little bit later. As for focus group, it had the largest effect on disparity, absolutely. So will definitely be used as a predictor in the model. Similarly, reference group would show the same thing and is needed conceptually for defining a comparison group with the focus group. That way we can predict disparity more accurately. As I mentioned before, it's important because focus group is split up into all the different demographic categories when we're analyzing them as I did before, but we want to use age, employment, income, race, and mental health all within this model because they're all, as you can see in the plots, they're all very important when it comes to calculating disparity. So rather than create one model, I created five different ones for each of the demographics and then put them into a list, model list down here. And then I applied just some summaries and different plotting techniques in order to make sure that each of those was also significant. If you scroll through these, you can see that the R-squared values and p-values are significant for each of the models and each of the predictors. I'll go ahead and go to the bottom though, because there's a lot to look at. Everything appears to be significant besides non-Hispanic white group in the race and ethnicity demographic. However, this is just indicates that the smoking habits of this group and the reference group, which is Hispanics, is just not much different. But I opted to include it regardless because the model itself was pretty significant. Then I plotted the residuals in histograms to make sure that each of the linear models was performing well. And as you can see, each of them is approximately normal with the mean centered around 0. There are some outliers, that's why the graph looks a little bit bigger, but I still think this is a good sign that our models are performing well. Then I plotted the residual versus fitted plots. Obviously, this one looks good. There is a little bit of grouping, as you can see, horizontally across the demographics. However, this is because the group nature of disparity within the specific demographic, so that's not necessarily a bad thing or an indication that the model is going to perform poorly. So the final model I use for each one is we predict disparity from focus group cigarette use, focus group, and reference group. So if we want to take a look at the app here, you can pick both the focus group and reference group for each demographic category. So I'll just go through and pick some random ones that we can look at. So if we predict here, you can see that it creates an ensemble prediction from all of the different predicted disparities, and you can see all the listings and everything you've chosen in the table as well. So it basically just takes a mean of all of these predicted DISP reported values to create the ensemble prediction. And that is about it for that.
All right. And finally, just to kind of sum it up. So this project, as everyone's project, kind of looked over cigarette smoking habits between the demographics of age, employment, income, race, and mental health. And so we kind of went through and then we started with our plots. So what we kind of found throughout the whole thing going through it is that states such as like West Virginia, Kentucky, Tennessee, and Arkansas had the highest smoking prevalence, where a state such as Utah, they don't really have a high prevalence, but their disparity was kind of crazy. So that's kind of why we took in and looked at the scatter plot for that to kind of see if those were associated, which we found they really weren't. So kind of moving forward through that, we then created our linear regression and did our calculations for that, which Hallie kind of went over, and then created our Shiny app to kind of showcase all of our work as a whole. And yeah, we kind of checked through residuals to make sure everything was good. And overall, this data project showcases how smoking in the United States is influenced by the combination of age, mental health, income, employment, and race, and other geographical